Hello, welcome to another episode of Onion Design Automation's podcast series. We have been driving thought leadership ideas around semiconductor design by discussing design automation related challenges with our esteemed panelists. My name is Krishna Banka, your host for this podcast. I have over 2 decades of professional experience in semiconductors and electronic design automation. My guest today is Umesh Sisodia. Umesh is the founder and CEO of Circuit Sutra Technologies, a company focused on System C based shift left ESL methodologies. Welcome to the podcast, Umesh. Why don't you introduce yourself to our audience? Tell us about your professional progression.
Sure. So thanks, Krishna, for inviting me to this podcast. Myself, I have close to 27 years of experience in the semiconductor industry. And before starting Circuit Sutra in November 2005, I was working with Cadence Design Systems and Semiconductor Complex Limited. At Circuit Sutra, since the last 18 years, we have been focusing on System C-based ESL methodologies, like which are becoming essential for the designing of the complex chips of today's. So we played an important role in the evolution and adoption of systems in the industry. And in fact, I got an award from Systems Initiative for driving the standards in the Indian ecosystem. Back in 2012, I started a conference, India Systems Users Group Conference. In the very first year, it was attended by close to 200 international delegates. Uh, that's a pretty good number, considering that systems is a very niche domain, and systems at that time was in a very nascent stage. And further in 2014, we actually merged this conference with DVCon India. So DVCon is a premier industry conference of semiconductor industry organized by Accelera in USA, Europe, Japan. So I closely work with Accelera and the other industry leaders in India to bring this conference to India. And I was the first chair of this conference in 2014. So that's about me.
That's great, Umesh. So, how do you see the evolution of semiconductor design in general? Because you have a lot of background in semiconductor design and development. So, how do you see the evolution of semiconductor design in general and your domain, which is like electronic system level design in particular?
Sure. So as we know, I mean, since the inception of semiconductor industry, I mean, there have been continuous advancements on the multiple fronts, and because of which the chips are becoming more and more powerful, more and more complex.
Sure.
So, I mean, today it's not just chip is not just a, I mean, isolated component. A chip is becoming a system on chip, or rather a very complex system on a chip, which consists of like multiple processors and maybe huge amount of software that runs on it. So designing these kind of chips is not very easy. I mean, the
Right.
design methodologies have also continuously evolved to keep the pace. So, I mean, if we see historically, this evolution came in the form of, I mean, raising the abstraction of chip design. So, like we
Absolutely.
moved from, yeah, so we moved from like component level design to the gate level design, and then from gate level design to the RTL. So today, even the RTL is not sufficient. I mean, there are
Right.
several activities which are being performed at an abstraction level, which is above the RTL. So at
Right.
Circuit Sutra, that's our focus. Our focus is the abstraction level, which is above the RTL.
Right. So, what's your perspective on the traditional RTL to GDS flow? How viable is it for the modern day chip design?
So RTL to GDS flow, I mean, has become pretty mature now, I would say. I mean,
Mhm.
definitely it's an essential part of the chip design flow even today, but it's not sufficient, I mean, for designing the complex chips of today's.
Right.
So, I mean, RTL is good enough for designing a smaller block of SoC. So you can simulate and verify the smaller blocks, the smaller IP blocks of SoC. But it's not practically feasible to simulate the complete SoC or even the complete system because the simulation speed at the RTL level is actually extremely slow. So that way it's not possible to like, I mean, design and verify the complete SoC at the RTL.
You're right.
And today there is also a requirement to validate the chip along with the software. So that adds another complexity for which like RTL is not sufficient to tackle that kind of requirement.
Right. So definitely semiconductor technology has been becoming more and more complex because of more and more logic which is sitting on a square millimeter of wafer. So definitely. So I think Circuit Sutra has been playing their part in this industry evolution. So how do you? Let's think about what Sutra's recipe is to counter the complexities of modern day chips. We've been talking about these chips, right? Where multiple processors, chiplets, and software all are packaged together on
Correct.
a small piece of wafer. So what is your recipe to deal with such complexities?
So at Circuit Sutra, we mainly focus on advanced shift left ESL methodologies. So it
Okay.
involves like performing various design activities at an abstraction level, which is above RTL, using the high level languages like System C, C++, instead of using Verilog, VHDL, etc. So at higher abstraction level, the simulation speed is pretty high actually compared to the RTL.
Right.
And we can actually simulate the complete SoC, or we can even simulate the complete system along with the software. So it actually enables the hardware software co-design further. Now for achieving this kind of simulation speed, I mean, we have to deploy some concepts like, I mean, interface abstraction, timing abstraction, or functionality abstraction, etc. So
Mhm.
let's say if we take the case of a SoC. So in SoC, like we have multiple IP blocks, which are connected with the processor using the SoC bus, using the network on chip, etc. Plus, these have some external interfaces for data transfer, let's say HBM 3.0, LPDDR, or CAN, or USB, or like SPI, these kind of interfaces. And when we talk about even bigger systems involving chiplets, so there
Mhm.
are interfaces like UCIe, like which connects multiple chiplets together for the
Right.
data communication. So when we try to abstract these, so we have to, I mean, model these interfaces at the transaction level actually. So
Okay. So,
for the SoC bus, there is a standard TLM 2.0 which is used, but for the other interfaces, there is no standard as such. So we have to develop the specific transaction level interface for every communication protocols, etc. That way. So that's about the interface abstraction part. In terms of the timing abstraction, so we have to remove the clocks and actually try to model in a loosely timed fashion, or maybe in the untimed fashion, so that the simulation becomes very fast. And the third thing which is very important is to understand what portion of the functionality has to be implemented for a specific abstraction, for a specific use case of that model. So
right.
let's say if we take the example of, if we are developing the models for pre-silicon software development, I mean, in that case, we have to model only that functionality which is visible to software.
Right.
Any other functionality, we need not model microarchitecture and other timing details. Those things we don't have to model actually. So that's important. So at Circuit Sutra, we have a strong focus in this area, and we have a very strong expertise in this actually, in these methodologies.
Right. So that's great, right? I mean, you touched upon these shift left methodologies, which are becoming a part and parcel of the semiconductor design these days. Now, how about what are the considerations which are related to fine tuning at the concept level itself, even before the RTL gets finalized?
Yes. So when we talk about these shift left methodologies, so
Mhm.
there are mainly three broad areas in this. I mean, architecture modeling, virtual prototyping, and high level synthesis. So when a new SoC is conceptualized, the very first step is to come up with a very optimum architecture which meets the power, performance, area requirement for the targeted applications, etc. That way.
Sure.
Now at this stage, several crucial decisions has to be taken, like which processor to use, which IP blocks to use, I mean, from which vendor, and what functionality can be implemented in the software and what should go into the chip. So mainly the hardware, software, partitioning, etc. That has to be done at this stage.
Mhm.
So for this purpose, we develop the architecture models actually. So these architecture models can be used for architecture exploration and optimization purpose that way.
Mhm.
The second thing, like once we narrow down to one specific architecture, I mean, at that time we can develop the programmer's view register accurate models,
Right.
which can be used which can be used for pre-silicon software development.
Mhm.
Even before the RTL is designed, you can actually start developing and verifying your software.
Right.
Now, all these steps are being done before the RTL is done actually, or maybe in parallel to RTL. So at
Right.
this stage, if you find some flaw in the architecture or anything, if you think it might not work, you have time to modify it right in the early stage actually. That way. And the third thing is high level synthesis. So nowadays
Okay.
there are lots of algorithmic centric IPs, let's say image processing, video processing, deep learning, etc. So for these kind of IPs, instead of handcrafting the RTL, I mean, we can implement the functionality at a high level using C++ and System C, and
Right.
then using the SNS, we generate the RTL. So that will lead to like, I mean, reduction in coding time and reduction in verification time to the order of magnitude also. So, I mean, these are the basic things in this methodologies, basically.
That's awesome. So now let's spend a few minutes talking about the buzzwords these days. So I mean, as you would also agree with me, these days there is a lot of buzzword around artificial intelligence and deep learning. A lot of
Correct.
semiconductor designers and manufacturers have started employing different ways of using the strength of these new technologies in their work. So do you see any relevance to the shift left methodologies that you're talking about, specifically when you talk about these buzzwords or new technology areas?
I mean, definitely yes. So, I mean, today we are at a very exciting time, and we are going through the AI revolution, which is going to touch each and every aspects of our life going forward. And for us in the semiconductor industry, it's even more exciting because
Uh-huh.
this whole AI revolution is actually powered by the semiconductor chips.
Definitely.
I mean, if you,
Can't agree more.
I mean, so if you see the concepts of this AI, etc., has been since long time. But in the past, the chips were not powerful enough to run these kind of AI workloads, etc. Now the chips are becoming more and more powerful. I mean, that's why it's feasible to run these kind of workloads. And now when it is becoming feasible, then more and more innovation has started happening in the semiconductor to come up with a innovative architecture which is fully suitable for specific AI workloads, kind of thing, etc. So for designing such innovative SoC architecture, I mean, definitely effective use of ESL methodology is very important actually.
Mhm.
So, I mean, if we talk about AI chips, deep learning chips, so in the architecture, there are mainly innovation which is happening on two fronts. One is the compute, and second is the memory architecture. So in the AI kind of workload, the kind of processing that happens in the chip, it actually requires massively parallel computing on a huge amount of continuously moving data. So, and during the architecture definition, the primary consideration is to come up to optimize the performance, to optimize the power consumption for the specific target use case, etc. So that's where this architecture model in the ESL methodologies that we develop, I mean, that becomes helpful. And again, once we have narrowed down on a specific architecture, then these virtual prototypes or the register accurate models can be used to validate that this proposed architecture is going to work fine with various software frameworks like TensorFlow, ONNS, etc. So that's also very important to validate quite early in the cycle. And third thing, like, I mean, there is also a push to like accelerate the various neural networks inside the chip itself to
Right.
achieve desired performance. So for accelerating these, I mean, neural networks, there is a role of high level synthesis. Like instead of handcrafting the RTL, I mean, we can implement the functionality at high level, or there are lots of neural network algorithms available in the software domain actually. So we can take this software and make it synthesizable, and then using the HLS, we generate the RTL. So that way, I mean, effective use of ESL methodology is very important for these AI DL kind of chips. Mhm.
Right, for sure. The Gen AI has been used widely, not only for infrastructure space, but for design space exploration as well. Now, if we talk about your customers, so I mean, would you like to, let's say, quickly touch upon the benefits of these shift left methodologies by, let's say, sharing some customer success story, and how do you see Circuit Sutra's role evolving further as you go along in the future?
Mhm. So we have been working with most of the leading semiconductor companies and some system companies. So by effectively deploying these shift left methodologies, the customers can find flaws in the architecture, in their architecture or functional specs or the functionality quite early in the cycle, and they can actually take the corrective actions very early in the cycle. The software development and verification can be started in parallel to the RTL development.
Okay.
That's pre-silicon software development. And moreover, actually, you can start the engagement with your potential customers quite early in the cycle, even before you implement the chip. Even before that, you can start engaging with your potential customers and try to validate your new architecture or your new chip, whether it's going to be fully suitable for their specific requirement or not. And if any
Sure.
changes are required, you can do quite early in the cycle actually. So overall, I mean, it significantly reduces the cost and time to market, and it significantly increases the probability of the success for the next chip. I mean, as
Sure.
far as if we see our customers, I mean, we are working with leading players in various domains like automotive domain, storage domain, AI and DL kind of chips, etc. And we are helping them to like successfully deploy these methodologies. And I mean, if we see at Circuit Sutra, so our primary mission is to accelerate the adoption of these system-based methodologies in the industry. And one of the primary challenge in the industry for the adoption is that these kind of methodologies require very unique skills actually, which is a combination of computer science and the semiconductors. So, and there is a very shortage of like right kind of people in the industry who have right kind of skills for that. So at Circuit Sutra, like we provide the SOC modeling services through which we set up the world-class modeling teams, which work as the extension of the customer's team and help them execute their modeling projects and deploy ESL methodologies. Over the period of time, we developed some reusable methodologies, I mean, which we use internally as well to ramp up our team members so that we can actually groom non-modeling engineers to become a modeling experts very fast. And these are also used by our customers to get started quickly with their modeling projects. And we have a highly specialized like system C training programs,
Okay.
again, for our internal use as well, and also to help our customers to get started quickly. So as a company, like we are a highly focused company. I mean, we don't do anything else. We are fully focused on ESL methodologies. And perhaps we are the only company, I mean, today, which is 100% focused on ESL methodologies and which understand all the aspects of ESL.
Sure.
In India, we are already recognized as the experts in modeling and the leaders in modeling. Going forward, our objective is to become the global leader in these ESL methodologies. I mean, so that we can serve the customers globally and help them design the more advanced chips of today than tomorrow.
Sure. Definitely. So semiconductor chips have gone through massive miniaturization, and Circuit Sutra for sure has been pioneering the deployment of innovative shift left methodologies, like you just discussed, to simplify the complexities of this modern day SoC design and PP optimization. Well, wonderful conversation, Umesh. Thank you again for your time.
And thanks, Krishna. I mean, thanks for inviting me to this podcast.
Well, that concludes our podcast. Any topics you would like us to cover, please leave a comment. And until next time, take care.